Let's look at how SPARKL can bring more powerful local analytics and closed-loop automation to the world of IoT. SPARKL is a distributed intelligence solution where analysis is done and decisions are taken as locally to the source of data as possible. This promotes natural scalability. SPARKL combines local distributed intelligence with big data analytics as needed. SPARKL provides out-of-the-box integrations, such as with Everything and Cisco Spark, to enable easy orchestration of end-to-end behaviors, supported by easy-to-use programming patterns, such as finite state machine. We take an example from the pharmaceutical industry, where factory machines comprising a drug pill production line will have many sensors giving measures such as vibration, temperature, speed, and so on. In the example, if one or more of the measures exceeds their respective normal operating range, then it may be indicative of a problem that warrants investigation. In SPARKL, we configure behaviors as mixes of actions that may be taken on various service endpoints. An action may be to pull in sensor data from a REST interface, for example. Another may be to send a message to Cisco Spark. But to start with, let's log in and create a very simple mix, just so I can show you the dynamic editing capabilities of the SPARKL developer console. So in this simple test mix, we're going to add a single operation, a solicit, and it's against the sequencer service, which is going to dispatch the operation and its field data on our behalf. We add a single field called in, and we say that the response of the solicit operation also consists of that single field in. We also need to add authorization for executing the solicit operation, and also add a declaration concerning the in field. And that just demonstrates the ability to dynamically edit mixes using the developer console. So let's execute the single try me solicit operation, and we're going to feed it a string, and we can see that we get that string back. Now that we've seen how easy it is to get started with SPARKL, let's go back to our pharmaceuticals example. There are two main components to the implementation of this example. One set of mixes corresponding to event sources through which data is pulled into SPARKL, and another set of mixes which act on and process this data. Let's look at the first mix. This would be written by a person who is responsible for making the sensor data available and also possibly recording it. For this demo, we'll make use of some Python which generates some vibration data, but we could have similar code which pulls the data into SPARKL from a REST interface provided by the sensor manufacturer, say. SPARKL Analytics works on the basis of transforming incoming data, persisting it, and performing processing on it. We can wire together transformers, persisters, and processors together in arbitrary ways. Here we see a transformer service. This will remove unwanted chaff from the incoming event. We also see a local cache service. This will store the last events from a particular sensor in memory, so that local analytics may be done subsequently. We see a persister that routes the incoming events to Everything, and another which routes them to MongoDB. Below these service definitions, we see a bunch of operations on these services. SPARKL will orchestrate a workflow that it executes on these services for every event that comes in. At the end, we can see an operation called fire notifies. This will be called after the transformer and persisters have acted on an event. This calls processing operations in any mix which name the key that's shown here. This mix dumps sensor data to Everything, as we've already described. In fact, we've already started this mix along with another for processing the data. This other mix sends alerts to Cisco Spark and actions to Everything. The processing mix uses SPARKL's finite state machine abstraction. This will send alerts concerning the state of the pharmaceutical machines being monitored, where these alerts describe the pharma pipeline as being in a red, orange or green state. Before we get into details of this processing mix, let's look at Spark and Everything to see what's been sent already. Here we see that a message has already been sent to Spark indicating that the pharmaceutical pipeline is in a green state. And if we check out everything, we also see that we're in a good state, here displayed as a white action. Also note the accelerometer data, which is being updated. In fact, let's just see what happens when we change the value of the accelerometer X measure to one that will trigger the finite state machine to go into a red state. So back into Spark, we see that a message indicating that the FSM is in a red state has indeed been sent and received. And in everything, we see that we have a value of 1 for accelerometer X, which is sufficient to trigger a red state for the FSM. And let's just see the actions, and there it is, an action indicating the red state. So let's move the FSM to an orange state and see the alerts again. In Spark, we see the orange alert, and if we click on the link, we go to everything. We see that the value of accelerometer X has dropped slightly, and we see a yellow action this time indicating the orange FSM state. Here we see the data that has been routed by SPARKL from the accelerometer sensors to MongoDB. We can write a simple query over this data, grabbing the time and value for the accelerometer X measure, and visualize the result. Here we see quite distinctly the step changes in value, starting very low, corresponding to a green state, and then high for a red state, and then dropping off again to an orange state. SPARKL is rich in its integrations, and in the case of SLAM data, SPARKL leverages this open source technology to make SPARKL reporting and analytics easy to do out of the box. An example would be auditing the service endpoints to which data has been routed by SPARKL. In summary, local and distributed analytics is at the heart of SPARKL's distributed intelligence solution. In this video, we've seen some simple local analytics on incoming event streams being performed in order to determine the next course of action based on finite state machine state. In the future, machine learning also could be applied here to ease the definition of what incoming event streams mean and thus what actions should be performed. The wide range of integrations that SPARKL makes available out of the box means that high-value end-to-end workflows are easily defined, as we've seen here, with events and alarms being forwarded to Spark and everything. SPARKL brings power and ease to making IoT work. Thanks for your time.